Yeah, it's good to be here. Super excited to speak to you guys. It's funny, I was reflecting before I was going to give this presentation. When I was at the last N100, I think it was pre-ChatGPT, and I mean, as someone whose job it is to follow AI trends, that seems like a lifetime ago. But maybe in some of the policy discussions that we're going to have a little bit later, we could discuss some of the ways in which the landscape has evolved. So before I actually tell you guys what's going on in AI, I'm going to try to convince you to actually want to listen to me. What is the AI Index? So the AI Index is a report that's now in its 7th edition, and it was introduced in 2017 by a diverse committee of AI thought leaders. People like Jack Clark, who's now one of the co-founders of Anthropic, arguably OpenAI's biggest rival, Eric Brynjolfsson, who is a leading expert and economist on the topic of AI and automation, as well as James Manika, who's a senior vice president of research at Google. And a lot of these thought leaders came together because they understood that AI was really going to be this groundbreaking, game-changing technology. And as such, it was going to become important to have a tool, a report or an index, that really tracks which countries are ahead, what's going on in the realm of policy, what can this technology actually do, and that's exactly what we look at in the index. The report comes out once a year. The most recent one came out in mid-April. The last one was pretty long, 500 pages, but we cover a lot of different topics. So we look at, again, trends in research, trends in policy, trends in ethics, trends in technical performance. I like to joke, but I think if there's any questions that you have about AI, I can bet you that you'll probably find the answers in this report. And to get some of this data, we collaborate with a diversity of data vendors. We also collect our own data for questions that we feel are particularly important. And we've had the privilege in the last few years to be widely cited in newspapers across the world and to also be cited in a lot of government reports. So with that said, I have 15 minutes to distill 500 pages. Again, don't let this distillation stop you guys from actually reading the report front to back. So let's talk about some of the key takeaways here. And the first takeaway, if I could kind of define it in a, let's say, more layman's terms, is that AI is just getting a lot better, a lot more quickly. What you see on this slide is you see the quality of generations from Midjourney. So Midjourney is arguably one of the world's leading text-to-image models, and we asked Midjourney to generate a hyper-realistic image of Harry Potter. And we asked Midjourney this question from the original version, which was released in February of 2022, all the way up to the most recent version that was released in December of 2023. And I think this juxtaposition really puts into perspective how much better AI has gotten. I mean, I like to joke when I do this presentation that I'm honestly probably more impressed by the generation on the left, because it's a very Pablo Picasso abstract take on what hyper-realistic Harry Potter looks like, but obviously not what we asked it to do. And the one on the right, you really have to almost squint to see that that is not in fact Daniel Radcliffe. And this kind of reflects not only the massive gains that have been made in this technology, but just the staggeringly high amounts of investments that people are putting into it. Now, where does this actually leave us on a high level? If you look at a lot of different benchmarks, so for those of you that are unfamiliar, benchmarks are these tests that AI researchers use to evaluate how well AI systems can do various things. On a lot of benchmarks, AI systems have already exceeded human capabilities. So this is what you're seeing on this chart. You're seeing benchmarks that are representing different human reasoning tasks, like classifying images, doing natural language inference, or doing visual reasoning. And on virtually every single benchmark, with the exception of those for competition level mathematics and visual common sense reasoning, AI systems exceed the human baseline. Now, the story here is not only one of AI systems being better than humans at certain tasks, but also really the pace of improvement massively going through the roof. So if you see on this slide, the blue line on the far left side of the graph, that's a benchmark called ImageNet, which was created by Dr. Fei-Fei Li, one of the co-directors of Stanford High. ImageNet is arguably the canonical AI benchmark. It was like one of the original ones that was released, and really kind of set this revolution of benchmarking and testing AI in this kind of way. You'll notice that the line for blue is pretty flat. It took the AI research community 3 to 4 years to actually get to a point where they exceeded the baseline, and it was a usable benchmark for a pretty long time. Fast forward on the right, you see this kind of teal line that's sharply going through the roof. This is a benchmark for competition level mathematics that was released in 2021. And the first AI systems that were tested on this did terribly, like close to 5% relative to the human baseline. And now the best systems are almost at that baseline level. And by the way, the baseline for this benchmark is the performance of a 3-time International Math Olympiad gold medalist. So it's not like I'm doing these competition level math problems. It's someone that could actually do them pretty well. So AI is getting good, it's getting better exponentially. I think one big question is, why is this happening? Well, I think one thing that we're really starting to see is we're starting to see that industry players are really dominating the conversation when it comes to AI. And this has a lot of very important policy consequences that we can maybe chat about a little bit later on in the day. This slide is looking at the number of notable machine learning models by sector. Are they coming from academic institutions like Stanford and Harvard? Are they coming from industry shops like Google and OpenAI? You'll notice that up until 2014, the majority of these systems came out of academic institutions. Since then, a massive gap has opened up until the point where, as of 2023, there were 51 significant systems that came out of industry compared to just 15 that came from academia. And when you look at the breakdown of foundation models, so these are again these models like GPT-4, Gemini, Claude that can do a lot of tasks at a very high level and are trained on massive amounts of data, you see a very similar breakdown. And again, since 2019, the leading institutions in terms of publishing a lot of these models are unsurprisingly the Googles, the OpenAIs, and the Metas of the world. So industry is doing well. Why is industry doing well? I think this chart really explains the picture on a high level. And that's just that training a lot of these frontier systems, so that's again these cutting edge AI systems, just costs a lot of money. So an important point to be made here is that when GPT-3, so GPT-3 was the model that came before ChatGPT, when it was launched, one of the things that they discovered in that paper is this concept of the scaling laws. Who has heard of scaling laws when it comes to AI? A couple hands are going up. So scaling laws is this idea that if you take a transformer architecture, so that's one way of building an AI system, and you just train this system on more and more data, you scale it, you are going to get better performance. So that's basically what these companies have started to do. They've just built bigger and bigger systems, and naturally when you build bigger systems, you need a lot more computational resources, and you need a lot more money. So the original transformer, which again introduced this architecture that set off this AI revolution, cost around $1,000. You fast forward to 2023, and some of the world's state-of-the-art models like GPT-4 and Gemini, we estimate cost anywhere between $80 million and $190 million to train. And again, this chart tells you the story very clearly. If you want better performance, train on more data. If you want to train on more data, you need better computational resources. As you scale compute on the x-axis, you scale the cost on the y-axis. There's also a valuable geopolitical question to be asked here, which is where are these models coming from? Who's leading the geopolitical race? Well, unsurprisingly, it's the United States at the top, and I think with a pretty sizable lead, followed by China, France, Germany, and Canada. Now, the European Union doesn't actually do too poorly here as an entire entity, but again, it's really the United States that is, at the forefront of a lot of this research work. And I think a really big reason beyond the fact that a lot of academic institutions are headquartered in the United States is just that, again, to build these really high-level models, you need money, and the people that can afford to do these things are the Googles and the Metas of the world, or the other kind of technical giants that are in Silicon Valley. Let's talk a little bit about responsible AI, ethics, and benchmark standardization. So one of the findings that we have in the AI index is that there really is a lack of robust and standardized benchmarks for evaluating the responsibility of the large language models. So what I mean by this is typically when a developer like OpenAI releases a new system, like when they're going to release GPT-5, they will release a technical report or a big paper. And on this paper, they typically test the model again on a variety of benchmarks or tests for how well the model can perform. And what you see here is you see 5 different developers and their flagship models, so OpenAI, Meta, Anthropic, Google, and Mistral, and you see some of the benchmarks that they test their models on. So you'll notice that when it comes to general capabilities benchmarks, these again are benchmarks that generally look at how good a model is. There seems to be some consensus. Everybody's testing their model on MPhil, which is a benchmark for general language understanding. Everybody's testing on Codex, which is a benchmark for coding capability. And everybody tests on GSM8K, which is a benchmark for mathematical problem solving. But when you fast forward to the world of responsible AI, so benchmarks that are trying to test how responsible these systems are, like what is their propensity to just give you false information? Truthful QA looks at that. How toxic are they when they generate the responses? Or how biased are they? That's what Bold and BDQ look at. There really is no consensus. And it's not clear if this is because different developers feel that different models are more salient than others, or if this is the case that model developers are just cherry-picking benchmarks that they think are particularly meaningful. But as we're moving into a world where AI is increasingly used by everybody, it's very important to have standardized comparison of capabilities, but also these responsible capabilities, because that's where you can have a lot of misuse and a lot of harm being done. 6th takeaway, and perhaps probably unsurprising to anybody in the room, the amount of investment in generative AI technologies has skyrocketed in the last year. We went from roughly $3 billion US of this kind of investment in 2022 to over $25 billion in 2023. Now, a 7th highlight that I think is probably one of the most important highlights of the report is that there is now a lot of evidence from a variety of different studies across a variety of different industries that suggests that AI is associated with greater productivity and higher quality work. So what you're seeing on this slide is you're seeing the cross-study comparison of how fast it took groups of individuals to do certain tasks. And this is from 5 different studies, and in each of these studies there was one group that didn't have access to AI tools, and there was another group that were told to do the exact same task but had access to the AI tools. They either had access to Copilot, which is a Microsoft coding assistant, or GitHub's Copilot, which does pretty similar things. And the 100% is the kind of baseline level. So like how quickly did the group that didn't have access to AI do things? And you'll notice for all of these studies, the group that had access to AI got their work done a lot quicker than those that didn't have access to AI. You see similar results coming out of studies of consultants. When you gave consultants GPT-4, the group that had access to AI did work that was of substantially higher quality. They did their work a lot more quickly, and they also were a lot more productive than those that didn't have access to AI tools. Now, there's an important caveat here. There was a really interesting study we profiled in the index, which looked at people getting different types of AI. And in this study, there were 3 groups of people. There was one group that didn't get any AI. There was another group that got, or the 2 other groups, they both got the same AI, but one of those 2 groups was told that they were given a good AI that was really good at its job, and the other group was told that they were given a bad AI. So an AI that was good, but sometimes had a propensity for making mistakes or hallucinating. Now, when you actually compare the performance of these 3 groups on tasks, both of the groups that had access to AI did a lot better than the group that didn't have AI. But of the 2 groups that were given the same AI but with kind of different labels, it was actually the group that was given access to the bad AI that did a lot better than the group that was given access to the good AI. And the researchers basically speculated that what happened here is the group that was given the good AI just kind of went on autopilot. They stopped checking the outputs of the models. And if any of you have ever actually worked with these AI systems, you'll realize they're good, they can do a lot, but they also are prone to making mistakes. So keeping humans in the loop is very important. An eighth highlight is that scientific progress is really accelerating as a result of AI. You have new developments like AlphaDev that have improved computer sorting. I think typically when I talk about the progress in science, the one model that I really like to highlight is alpha-minescence. So for those of you that are unfamiliar, a minescence mutation is a mutation to a human protein structure. Scientists estimate that there are 75 million different minescence mutations. Alpha-minescence is a model from Google that tries to classify these mutations. Prior to alpha-minescence, human annotators were able to successfully classify 0.1% of all mutations. Then alpha-minescence comes onto the scene, and alpha-minescence has since then been able to classify 89% of all of these 75 million different minescence mutations. That's an example of the power of AI and what AI can do to accelerate science. On the regulatory side, it's perhaps not surprising to anybody that the amount of regulations concerning AI is really going through the roof in the United States and across the globe. And when you look at the story actually in the United States, it's the case that these regulations aren't just coming from one or two institutions, they're coming from a variety of different institutions. So the Executive Office of the President is getting on board, the Health and Human Services Department is also doing their thing. And this is really indicative of how AI is this broad purpose technology that is of concern to a variety of different regulators. Now, the final takeaway here, and I think this is a nice transition to some of the policy discussions, we're kind of really at an inflection point where AI is now here, it's occupying all of our minds, and it is now our responsibility to talk about it and to think about it. You couldn't really say this when I gave this talk at the last N100, because I would talk to policymakers before about AI, and they would kind of say, yeah, it's important, but you had the sense they weren't really concerned about it in a very deep way. Then ChatGPT has come onto the board, and now everybody is concerned and wants to act quickly. And that's really what you see on this chart. So Ipsos has done two surveys, one in 2022 and the other in 2023, where they asked people a variety of questions. To what degree do you agree with these AI-related statements? And this chart is looking at the percentage point change in opinions. So if you compare the 2022 survey, which came out before ChatGPT, and the 2023 survey, which came out after ChatGPT, how have the answers to these questions changed? And you'll notice for the box that I've highlighted, do you agree that products and services using AI make you nervous? For every country included in the survey sample, there was a substantial uptick. And this is, again, very critical and very important, because if we look at public opinion data, there are certain countries like China, like Indonesia, like Thailand, that are not in the West, that are actually very bullish about this technology, whereas there is others, like Germany, like France, like the United States, that are actually very pessimistic. And the question of how the public feels about this technology is actually going to be critical in determining where this technology goes in the future. So that wraps things up for me. Excited to hopefully have given you guys a foundation to understand what's going on in the AI world. Hopefully we could take some of these discussion points and topics into some of the roundtables we're going to have soon. And again, I've put up a QR code of the report just in case you want to rip through it when you have some free time. Thank you very much.